Okay, this is section 8.5, the law of sines. The law of sines is something we can do for non-right triangles. And here is our law. Make sure you put this in your notes. Sine of capital A over lowercase a equals sine of capital B over lowercase b equals sine of C over lowercase c. This applies to any triangle, does not have to have a right angle. But the capital letters imply angles and angle measures. A, B, and C. The lowercase letters are side lengths, and they must be across from. So notice that capital A, lowercase a is the side across from angle A or capital A. Lowercase b is across from capital B, and lowercase c is across from this. Now, you're not used to equations with two equal signs in. You do not need two equal signs. Okay? You use whichever two of these three fit. So looking at this in a problem. Let's do example 1. Make sure you put this into your notes because I can't keep everything here on the screen. But we have a triangle that looks like this. This is probably a bad drawing, but 15, 48 degrees, 93 degrees. And we are asked to find side A, find side BC. So we know that this is AC. AC is 15. We can label that as lowercase b. We can label this as lowercase a because that's what I need to label it as. It doesn't ask me to do this, but I'm going to do this anyways because it's good for future knowledge. Remember that the three angles of a triangle add to 180. And I have two of them. I have 48, I have 93, and I have C. And if I subtract 87, this angle up here, I'm just computing to be 39 degrees. Okay. I don't need that actually for this problem, but it's good information for the future. So I'm looking for little a. I know that sine of 48 over little a equals sine of 93 over b. So I'm using sine a over a, sine b over b. Wait, I don't need to have it as b. B is 15. I know that one. Anytime I have a proportion like this with an equal sign between them, this only works with the equal sign in the middle, I can cross multiply. Which means I'm doing 15 times sine of 48 equals a times sine of 93 degrees. Make sure you're using a calculator in degree mode. If you're using the Chromebook, it probably comes up in radian mode, so make sure you switch it. Now, to solve, I will divide both sides by sine 93. And I'm going to use a calculator. I'm going to show you how to use the calculator. Okay, so here we have the calculator in front of us. To do this, we can do, I'm going to put my numerator at my top, which was, I'll write it out on the screen too. So I was going to just try to enter 15 sine 48 degrees Nope, I'm in the wrong mode on this calculator, sine 93 degrees. So I'm going to quick switch the mode. Hopefully you have it switched correctly on your calculator. Remember, if you're using the Chromebook calculator, you're going to have to switch that. So I'm going to do my numerator, my 15 sine 48, I'm going to put in parentheses. But I need to hit 15 times sine 48. I close my parentheses on the sine and the 15, and I can divide by sine 93, and that gives me 11.16. So that says my length of my side of the triangle is 11.16. And unfortunately, it lost all my drawings when I switched that. So I had the triangle here. That's not a very good drawing. With 93 degrees here, 48 here. 15 was this side length, and I got 11.16 for this side length. Example 2 gives you this triangle. And it asks me to find measure of angle S, which is this side. Those labels for the law of sines are really about positions. It doesn't matter what the letter is. So 11 goes with S. So I can set this up sine S over 11 equals sine 120 goes with the 18. So I can set that up like that. I will cross multiply here, just like I did before. Anytime I've got a proportion like this with equals between them. And I get 18 times sine S equals 11 times sine of 120. Well, I'm trying to get S by itself. So first thing I need to do is move the 18 away. I can do that by dividing both sides by 18. I'm just showing this in a different color to make it handier to see that I added a step here. And I've got sine S equals 11 times sine of 120 over 18. And I'm going to grab a calculator and do that. And I get 0.592. Anytime you have a sine or a cosine of an angle, you should get, or 5292, you should get a decimal. Now, to get the actual angle, I'm going to use the inverse sine. And then that's second sine on your calculator. And I get angle S. The measure of angle S here is equal to 31.95. It told me to round to the nearest tenth. I'm going to round that up to 32.0 degrees. That was example 2 or problem 2. Let's do example 3, which is a word problem, but it's really kind of about the same thing. They say a ship has been at sea longer than expected and has only enough fuel to safely sail another 42 miles. Port City Lighthouse and Covetown Lighthouse are located 40 miles apart on the coast. And it gives you a Port City is PC, Covetown is CT, and it says this is 40. At sea, the captain cannot determine the distances by observation. The triangle formed by the lighthouse is shown. Can the ship sail to either lighthouse? Out here you have the ship. It says 70 degrees to Covetown or Port City and 52 degrees to Port Town. So this is an example where I can find this third angle because they all add to 180. So 180 equals, I'm gonna call it X. 70 plus 52 plus X. And X is going to be, when I subtract 70 and 52 from 180, I get 58 degrees. Now I have the angle across from 40. With my law of sines, I must have an angle and a side that are across from each other. Let's find this one. That one feels like the shorter one, so I'm going to see if it'll work for that. So I'm going to do sine of 58 over 40 equals sine of 52 over, I labeled that side little b. I will cross multiply and get b sine 58 equals 40 sine 52. I'll divide both sides by sine 58 to get b. I get b equals 40 times sine of 52 over sine of 58, which equals 37.17. And it can go 42 miles, so it can go to Port City. Okay. I chose the shorter one. As soon as I found one that works, I'm going, yes, we're going there. Okay, that is section 8.5.